Hello everyone, this is part 2 of Signals and Systems. In this session, we will discuss classification of signals. Based on the nature and characteristic in time domain, signals are broadly classified as continuous time signals and discrete time signals. Let us understand what is continuous time and discrete time signals. A signal is called a continuous time signal if it is defined at all instants of time. So, from the word continuous, we can understand that the signal is defined continuously. Mathematically, we can say that a function is continuous if it is defined at all instants of time, whereas discrete represents if a signal is defined only at discrete instants of time. Generally, continuous time signal is represented x of t, whereas a discrete time signal is represented by x of n. So the next question comes into our mind is there any relationship between continuous time signal and a discrete time signal? Yes, we have. We'll obtain a discrete time signal from continuous time signal by performing sampling process. So after performing sampling on x of t, the resulting signal is a discrete time signal. So we can represent x of n is equals to x of t, and where t is equals to nts. This ts represents sampling period and n is integer value which the x of n takes. I hope that you will be able to recollect sampling from communication theory. Even if you are not, don't worry. We will discuss in detail sampling in an analog and digital communication tutorial. Now let us look into graphical representation of x of t and x of n. So to represent a signal x of t on x-axis, we will consider time value, and on the y-axis it is amplitude x of t. So for example, if a signal is defined like this, then it is called a continuous time signal. If you look at here, we can find out the value of x of t at any instant of time. So it is called a continuous time signal. Whereas a signal is called a discrete time signal. In discrete time signal, to represent on x-axis we will consider n, that is integers, and on the y-axis x of n. So x of n will be represented as like this. So if you look at this representation, we can say that the signal is not defined at these instants of time. Such type of signal is called a discrete time signal. These continuous and discrete time signals are further classified. Let us look into further classification of continuous and discrete time signals. Even and odd signals, that is based on the symmetry condition. Periodic and non-periodic signal, that is based on the repetition of the signal. Deterministic and random signals, it is based on the value of a signal at particular instant of time. Energy signals and power signals, that is based on the signal energy and power. Let us discuss all these type of signals with simple and easy examples. First one, even and odd signals. Signals which are symmetrical about the origin are called even signals. Mathematically, if a signal x of minus t is equals to x of t, then it is called an even signal. Whereas the signals which are anti-symmetric are known as odd signals. So mathematically we represent it as x of minus t is equals to minus of x of t. Such type of signals are called odd signals. So when I say x of minus t is equals to x of t, the common examples which will come into our mind are t square, t power 4, cos t, etc. Right? Whereas for the odd signals, t, t cube, sin t, etc. If you look at these signals, In place of t, if we substitute minus t, the resulting function will be same as original function. Whereas here, if we substitute t is equals to minus t, the resulting function will be minus of original function. Now, let us look into graphical representation of even and odd signals. As mentioned, both continuous and discrete time signals we will represent over here. So for a continuous time signal, on time axis it is t and on y axis it is x of t. On x axis it is t and on y axis it is x of t, right? So if a signal is defined like this, so if you look at here, the signal is symmetrical about vertical axis. And this part is reflection of this part. So we can say it as an even signal. Whereas in discrete case, the signal will be represented like this. As mentioned, on x-axis it is n and on y-axis it is x of n. Let us look into odd signals. First, we will consider a continuous time signal. There is a time and this is x of t, right? So it is called an odd signal if it is defined like this. It is a reflection of the original signal with a negative value. So in case of discrete, here it is n and this is x of n. The signal will be represented like this. When you look at these observations, it will be negative of the original value. So such type of signal is called odd signal. One more point to remember is any signal x of t is a combination of even part, that is x e of t, plus odd part, that is x o of t, right? In next session, we will discuss other classification of signals. Please subscribe to our channel for latest updates. Please feel free to provide your questions or comments in comment section. Thank you for listening and have a great day.